To take a moment to talk about um, the list comprehension that we used with a guard, and we did that to filter out the vowels from the lowercase ASCII letters so that we could end up just with the consonants. And so I can show it here. For this, I'll need to import string, and I can set the vowels equal to A, E, I, O, U, and then I can, again, we can look at what is string ASCII lowercase. That's just a string. And we can iterate through each of these, say for C in that. Um, and we could say C for C in that. And that creates a list of those characters, which is actually just exactly the same as saying list of string lowercase. Um, but what we're doing here by doing this list comprehension is we can say if C is not in vowels. And then we can get a list of just the consonants in the ASCII lowercase. There's another way that we could write this. And I can um, put that into consonants. And I want that to be a string, so I'm going to join those back together. So what is consonants? It is what we'd expect. Another way that we could write this is using a filter. So we saw this with map. That map is a higher order function that takes some function, f here we might call it, and some list, some iterable, some sequence of items. And each item will be passed through this function, and the result of that function will create the value of that element in a new list. And filter works very much the same. It expects also as its first argument a function, but this function, rather than modifying the element, it should return true or false, or something truthy or falsy, that will determine whether or not this element should be included in the resulting list. And so map and filter always produce lists. They always produce iterables, another sequence. The length of a map is always going to be the same as the length of the list. It's going to transform every element by the function. But a filter is always going to be equal to or less than the size of the input list, because some of the elements may not come out. So another way that we could write this would actually be like this. I'm just going to copy and paste it for the moment so we can look at it. If I say consonants here and I say what is consonants, it's exactly the same list. And what we see here is that if not C in vowels is the same as what's going on here in the lambda. So the lambda is going to take the character C, it's going to take some element. We're calling it C here. That's the name of the variable inside the lambda. And we're saying C not in vowels, which is exactly what is the condition here in the guard. And here we have to say for C in string lowercase. Well, just as with map, we don't have to say for C in string ASCII lowercase. We'll just say string ASCII lowercase, and it will automatically take each one of the characters, put them into C, and then this will return true or false, whether or not that is or is not in vowels. And only the C, only the characters for which this is true, will be let through the filter. So that's just another way of writing a list comprehension with a guard. You could use a filter. To me, it's a little cleaner. I just prefer this syntax often. I don't actually enjoy writing the word lambda, though. I wish there was a shorter way in Python to do that. But the list comprehension with the guard is extremely Pythonic and is a very good way to write that. If we could just take another example here, if it might help you to understand it. Let's say we have a list of cars, and there's one is a blue Honda, a red Chevy, and a blue Ford. And if we only want to let through the cars that start with blue, then we could write something like this. So the filter is taking a lambda, an anonymous subroutine here, and it's going to get each individual car, and we're going to say car starts with blue space. And so, you know, if the car, for instance, is when the car is the red Chevy, and we can say car starts with blue space, the answer for that is going to be false. So when the blue Honda comes through, it does start with blue, and so it's allowed through. But when the red Chevy comes through, it does not start with blue, and so it's not allowed through the filter. And so that is how a list comprehension, I mean a filter works. One more example here is if we create a range operator, we use the range operator to create the list of elements 0 to 5, and we want to say which ones are greater than 10. None of them are. And the important thing to point out here is that a filter is always going to return a list. That list may be empty, but there will be a list. It's the same as if we said we did the same thing with a list comprehension. The list comprehension returns an empty list because none of these elements pass this guard. Either way you want to write this, it's fine. I have a diagram here showing how you might go from the for loop to a list comprehension to a filter. The for loop, I think, is actually the worst way to write this, not only because it's so many lines of code, but also because you're relying on these side effects of adding the consonants to the character here to the consonants. I think the list comprehension is a much better way to write this. The filter ends up being not shorter, not necessarily a shorter way to write this, but a decent way nonetheless.